So, welcome back students. We are basically discussing local symmetry and pseudo symmetry, and in last lecture we have talked about a natural product whose structure contains local symmetry, means one part of the molecular structure is having perfectly symmetrical structure, and the remaining part there is some functional group is present that makes the molecule non symmetrical. So, then altogether the molecules become pseudo symmetrical. Now, we have explained that how a natural product bisocalamic acid can be synthesized by applying the concept of local symmetry and pseudo symmetry, and you said that strict maintenance of symmetry is a essential prerequisite. Now, next target or next problem we will try to analyze this similar concept for again a natural product whose name is oxidol. Now, this molecule is oxidol, is a terpene molecule, is basically a sesquiterpene. So, which is having C15 framework. Now, we see the structure of oxidol, you will find that the aromatic part is perfectly symmetrical. Okay. This part should be in principle symmetrical if this group was not there. So, the entire molecule is basically pseudo symmetrical, entire molecule is pseudo symmetric, and the aromatic part is basically having local symmetry. The left hand side of the molecule is having local symmetry. So, this way basically you can see the structural features of a given molecule, then you can predict that how. Now, oxidol was reported to be synthesized by a unique Wittig type of cyclization from two different regioisomeric compounds, either A or B. This was given in the literature. Now, the disconnection says that probably CO2Me and CO2Me will give you this tertiary alcohol, because you need alcohol here. Finally, you need alcohol here. It is basically alcohol functionality. So, if you ester, you react with excess Grignard reagent, methyl Grignard, you get the alcohol. Now, we see compound A and B, which both are proposed that this in both the intermediates can lead you this compound. Now, A and B basically are a regioisomers of a alpha beta unsaturated ketone. In addition, the other hint which was given to you, you have to also use this Wittig elite, that was given to you, Now, what I am trying to do, we will first trying to draw the oxidol structure again, as our target molecule, and then I say the initial FGI will be the Grignard reaction, fine. Now, where from the pseudo symmetry and local symmetry is coming, I will be talking to you little bit later on. I am say I am having this particular compound. Okay. Now, this compound is also similar, is basically this part is local symmetry, this part is pseudo symmetric, entire molecule is pseudo symmetrical. Now, what I am saying, this particular intermediate can be constructed, let us follow this pathway. I am saying that okay, you have this methyl, you try to put a double bond here, you try to put a this viticulite, which is basically you require, and then you are having a methyl C double bond O. I am saying that probably one of these aromatic double bond can be constructed through a intramolecular Wittig reaction. Now, you need to make a C6 unit. So, this is 1, this is 2, this is 3, 4. So, basically you need to have a 4 carbon 1, 2, 3, 4. So, you have this particular. So, I am saying that this disconnection probably we can do it, and then we do a intramolecular Wittig reaction, and then probably this one can be seen that how the starting material was related. I am saying that this starting material can be connected, and now the initial Wittig reagent which was given to you having a structure pH 3 P plus. Now, exactly what is this Wittig reagent? This is basically nothing, a Wittig reagent where the things are just like this. Now, eventually if you see a allylic carbanion which can also undergo resonance to put you or to give you another resonating structure where you have this thing. Now, I am saying that if this initial compound was given to you, you assume that there might be this kind of resonating structure takes place, and then this one is acting as a Michael nucleophile to this Michael acceptor. You see the structure both the methyls are on this terminus. So, one methyl is coming from this ketomethyl, and this methyl, if its initial Wittig salt undergoing this resonance charge transfer, normally this resonance thing, and then it gives you these things, you basically can attack it here, then you basically get this elite, you can close it. On the other hand, the same molecule you can also cut into another way, and here I am saying that you put the CO2Me here, that is fine, and then the ketomethyl you put it in this way. Then also you can have a another as a minus and P plus triphenyl phosphate. This also I said. So, this also can undergoes intramolecular Wittig 1, 2, 3, 4, 4 carbon. Now, how this compound can be accessed? This compound in reality can be accessed from this CO2Me and this COMe, this CO2Me and this COMe. Now, this is intermediate B and this is intermediate A. Now, I will do the for both the molecule I will try to do the forward pathway. Now, if you see this retro for a same target molecule is only possible because the molecule is having a local symmetry. That is what two regioisomeric compound either this or this will give you same target. Now, reaction pathway is almost similar because you only are touching this part remains unaffected, this part is remains unaffected in the entire synthesis. Now, let us talk about the forward synthesis and then consider. So, initially I will say take the intermediate 1, so or intermediate A. So, intermediate A is having this structure CO2Me, MECO, Me. Your vitigillite, as I said, it is going to undergoing or have this regenerating structure P plus pH 3. So, initially I said this goes in a Michael fashion, and if it reacts in a Michael fashion, this is compound A. So, what we will get? You will basically get CO2Me, this part is there, your methyl ketone is there. Now, your Michael attack of this vitigillite takes place, and then you are basically having this P plus pH 3. This is also a vitigillite. Now, this vitigillite can easily undergo intravitic reaction, intravitic. It will essentially give you a cyclic product. The structure of the cyclic product will be this methyl, this compound. Now, next what you need to do? You just need to aromatize the molecule. So, this hydrogen you need to basically remove. Normally, this is done by standard selenium carbon. It is oxidative condition, actually you need to remove these two hydrogen. So, you basically get the part, this part. Now, take with the another intermediate or another starting material whose structure is B. The structure of B is now just the regioisomer of the compound A. So, structure B. Now, here I am saying that this same intermediate attacks in the Michael fashion. So, this is now B. So, intermediate attacks in Michael fashion, this CO2Me is here, this COMe is here. Now, if it attacks in Michael fashion, you basically have this, and then you are having this your P plus and your PPH 3 actually. Now, here initially what happened, this hydrogen it seems to be acidic. I mean this, so this will put a negative charge, so that Wittig reaction can effectively be taking place. So, you basically put a double bond here, and then now you formulate the Wittig things. Now, it has become CH2, or you can basically get a negative charge here. I mean these things comes, this gives a negative charge, the phosphorus is there. So, you get a P plus pH 3, which is nothing a vitigillite. So, 1 2 3, this is 1 4. So, now if you do a intravitic, you get the same compound as earlier CO2Me, your this methyl is here, this methyl is here, this double bond is already there, you make this new double bond here. So, now these two are similar. So, again same selenium carbon, you get the aromatized thing. Now, if you see the entire forward pathway, so starting from a both the regioisomers and reacting with a crotyl Wittig system, you can basically come to a core structure. Now, this is only possible because the molecule is having a local symmetry. The left part of the molecule is having the local symmetry. This is the main thing which basically gives you a entire symmetrical or the local symmetrical consideration. Now, the synthesis can easily be completed once you have this intermediate which you have prepared. Just take this intermediate and react with excess methyl Grignard. So, basically get the target molecule. And actually oxidol is a very nice target molecule from a consideration of local symmetry and pseudo symmetry, and eventually other syntheses reported for oxidol also have a nice demonstration of how this part was done. The probably I will just try to give you another synthetic pathway where you will find that this oxidol how it has been constructed. I am saying that now I will make oxidol through a different way. Now, what is the different way? I say this aromatic ring, if you have to consider the late stage, do not keep this aromatic ring, just this aromatic ring, okay, we will draw the intermediate in different way. I am saying you draw the intermediate in this way, this methyl, this methyl, you put a double bond here, put a double bond here, and then I am saying if you do a 4+2 Diels-Alder reaction, that basically gives you the same intermediate. Okay. Now, what is this? This compound can be regarded as effectively very good diene. Now, this compound is having perfectly sigma V local symmetrical part, and this part is your pseudo sigma V, because due to presence of the CO2 Me, this is not perfectly symmetrical. Now, this diene is named as orthoquinodimethite. This orthoquinodimethite. So, that is a very now how you can generate this kind of intermediate. The usual way to generate is you take the corresponding dibenzoylic bromide, react with simple zinc, metallic zinc. If you react with metallic zinc, zinc Br2 will precipitate and you basically get the orthoquinodimethite as a diene. You react with this dienophile. Now, this is sigma V, perfectly sigma V. So, this gives the local symmetry part in the target molecule. This gives the local symmetry part in the target molecule. So, in this way you can basically consider. Now, what I am trying to do, I will give you a natural product which is perfectly symmetrical natural product, same like civetone, but this structure is little bit complicated. Now, see the structure very carefully. There are methyls here, and in the central carbon you are having a OH. Now, this molecule name is caryophyllene alcohol. Caryophyllene alcohol. This is a naturally occurring sesquiterpene. This is a naturally occurring compound, or you can isolate from nature. If you see the molecule, this is a 3 ring, 1, 2, 3. In addition, this 5 member and 6 member ring, it forms a bridge, actually it is a bridge connection. Now, this molecule have a nice sigma V as you can formulate, okay, sigma V. Now, synthesis of this molecule was done by following a very nice concept of exploration of local symmetry and pseudo symmetry. So, what I initially do, I will say the initial or the particular OH will be introduced at a late stage, and we say if you have this methyl, if you have a carbocation which can be easily trapped by this water to give you this thing, this carbonium ion is perfectly sigma V. Okay. Now, this carbonium ion is basically kind of a breached carbonium ion, okay, breached carbonium ion. Now, I am saying this breached carbonium ion can be constructed by some classical carbocationic rearrangement which you probably seen in the pinacol rearrangement. Now, I say if you have this carbonium ion which is definitely a 3 degree carbonium ion. Okay. Now, in addition this carbonium ion is 3 degree, okay, tertiary, but this also contains a strained 4-member ring, 4-member ring. So, this is a very important point. The strained 4-member ring in this particular carbonium ion lead this carbonium ion to undergo 1-2 migration. Now, if this carbonium ion, this bond basically migrates here, the 4-member ring is expanded to a 5-member ring and putting a carbonium ion or electropositive thing at the central carbon. Now, where from this carbonium ion will be generated? Now, the symmetry has been disturbed. Now, the molecule is becoming basically local symmetrical. This part is symmetrical, this part is not. Now, the molecule become local symmetrical. Okay. Now, what is it? Okay, this compound you can easily prepare starting from, I say, this methyl and this OH just by water removal, Okay. So, this compound is again same local symmetry as well as pseudo symmetry. This part is local symmetry, this part is pseudo symmetry. I will say you need to have a tertiary alcohol center. So, I am trying to put the corresponding ketone. Okay. Now, we are coming that you basically have this olefin, and if you having a alpha beta unsaturated cyclohexenone, the best way to construct the cyclobutadiene is 2+2 cycloaddition reaction. Now, if you now do the forward synthesis, you will see that your synthesis starts from this particular compound. Okay. You react with these things in a photochemical fashion, say 2+2. Okay. Now, after this 2+2, you basically get this cyclobutane, which is your photo adduct, and here basically the ring is strained. Now, initial starting material, this starting material is symmetrical. Okay. As our synthesis was basically having an extra methyl group. So, I have missed all the methyls here, it will be methyl, it will be methyl here, it will be methyl here. So, starting material is basically having methyls here. Now, this part is symmetrical, perfectly symmetrical, and this part is not perfectly symmetrical, this part is pseudo symmetrical. So, what I am now trying to analyze a perfect symmetrical part or perfect sigma V intermediate, plus you react with a pseudo symmetrical intermediate, gives you a molecule which contains local symmetry in one part and pseudo symmetry at another part. It is obvious. So, this consideration I am basically trying to highlight it. In normal textbook you will not get it. Basically the analysis through local symmetry and pseudo symmetry is very crucial and is a nice demonstration. So, fine, initially you do this 2 plus 2 reaction. Okay. Now, what next? As situation demands, you must react with methyl lithium to get the another methyl part. So, now you see if this after initial 2 plus 2, this part is local symmetrical and this part is pseudo symmetrical. So, this part I called LS local symmetry, this part your pseudo symmetry. Okay. So, now you do this methyl lithium addition, you have this methyl OH. Okay. Now, this compound, this particular compound you basically treat with a mineral acid or very mild acid, paratoluene sulfonic acid. So, initially what will be happening? You basically get the corresponding carbocation as explained earlier. Now, this carbocation will tend to migrate, is a 1-2 migration. Now, migration takes place like this. So, this part is local symmetry. Now, after this migration there is a very beautiful observation. Once this migration takes place, the 4-member ring now become a 5-member ring. The 4-member ring now become a 5-member ring, and as both the methyl groups are there, the earlier methyl part, this part makes it a local symmetrical molecule or pseudo symmetrical molecule. Now, here after this methyl migrates, this 2 methyl was kind of perfectly symmetrical orientation. The stereochemical part we did not consider. So, now if you see, this molecule now becomes symmetrical. So, a local symmetrical molecule or a pseudo symmetrical molecule, the molecule initially having local symmetry as well as pseudo symmetry, now converting to perfectly symmetrical intermediate. Now, this is only possible as the part of your molecule already having a symmetry, local symmetry, and by doing some transformation of a pseudo symmetrical part, you are bringing or you are creating. Now, pseudo symmetry is very close to symmetry. You basically need to rearrange or reconfigure the pseudo symmetrical part to convert it to a perfectly symmetrical part. That is what we exactly did here. Now, if you see it is perfectly symmetrical, you react with a water molecule and then you will find that your methyl will be there, methyl will be there, and you basically having a OH here. So, this pseudo symmetry and local symmetry probably is a relatively new concept to you, but definitely you can have a nice way of thinking this particular problems in this angle, and we will talk about desymmetrization, the remaining part in the symmetry based strategies in the next lecture. So, till then have a good time and goodbye.